Hi and welcome. This time around we have an interesting product from Vevor, which they sent me sort of unsolicited. It is a Mig Welder, 130 amp 3-in-1 Mig Welder. Now, I have no experience with MIG welding. I have never used a MIG welder in my entire life, and I told them this before they sent it to me. They said, go ahead, evaluate it anyways. So I will give you my best impression as a non-expert or even mildly experienced MIG welder user. Besides MIG, this guy also does TIG, lift TIG, and stick welding. So I haven't done stick welding either, but I have done a bit of TIG welding. I have a high frequency start TIG welder. This is a lift start TIG welder, which I believe means you put your tungsten on the material, hit your pedal, and then lift up, and as you lift up, the arc starts. Actually, this may not have a pedal with it. I don't think that's one of the options. It does say it has all copper ground lead, which is impressive because copper is expensive these days. As of last year, I'm sure everyone knows who watches this channel that metal prices have tripled to quadrupled, and copper was one of the first to go up. It's a 130 amp welder, so based on the estimate of 1/1000th of an inch per amp, that means it should be able to do 1/8 inch material in single pass. You can do much thicker material if you're willing to do multiple passes, and you know, put the appropriate bevel in the weld seam so that you can build it up. It handles between 8.2 and 42.65 feet per minute of MIG wire, and it takes MIG wire diameters 0.24 to 0.031 inch. It does not do the larger 0.045. Again, I have no experience with MIG, so I will do my best to evaluate this reasonably and give you a sense of how it's working. If I forgot to mention, this guy starts at $129.59 on Amazon right now, at least when I last looked, and free shipping, free returns, so that's pretty cool. I like the box. It arrived pretty unscathed, and it's triple thickness cardboard. Super heavy duty. I like that because a lot of stuff from Asia gets sent with really thin cardboard, but this is triple thickness, and the box arrived completely unscathed, so that's nice. Even for such an inexpensive item as this guy, they still kept the cardboard thickness up, which I'm pretty impressed with. All right, so it has really nice foam packing. They didn't use cheapo styrofoam. They used the expensive, I'm not sure what you call this kind of foam, but it's multiple layers glued together. Very good protection, so that's pretty impressive. As you'd expect for modern solid state welders, this is an IGBT welder, they claim. They're very small and very light, so this is an exceptionally portable unit. This thing is super light. Look at that, one finger. That is very impressive, provided it can handle the current that they say it can. The front panel has simple selection between processes, MMA, which I believe is stick, MIG welding without gas, and then with gas, MIG and TIG. And voltage between 1 and 10, current between 20 and 130 amps. You have very basic ground and, well, positive and negative leads out the front. And this is interesting. This must be for, I'm not sure. Whoa, yeah, I'm not quite sure. Oh, they probably got it tucked in here to protect it for now. So here's the side opened, and I hear MIG gun's already attached. Okay, so here's the MIG gun stored inside the unit for transport, which is kind of interesting. I don't think I would have expected that. And I know from watching other people's channels like Cutting Edge Engineering in Australia that MIG welders, one of the challenging parts of a MIG welder is the feed mechanism needs to be well done. So it'll be interesting to see how well this feeds wire. I don't have super high hopes because this thing is really inexpensive. Oh, you know, looking at this, there is no gas inlet. So I'm not sure how they do TIG at all. Maybe you have to feed gas down the hoses separately. It's not controlled by a solenoid, which means you need to have a gas valve to control the TIG. So that's not going to be very efficient to do TIG at all. The MIG welding, they're telling you with a big warning on the side here, use self-shielded flux cord wire because there is no option to put gas down this MIG torch. So it does flux cord only, so that's a good thing to observe. I think some of their bigger models in this range, in this series, they go all the way up to I think it was 270 amps. And I think the 270 amp in the model right under that does support external gas. So if you're looking for dual shield, then you want to do that approach. But this one is flux cord only, it appears. The MIG gun itself has a hanging hook that's built in, pretty nice and pretty sturdy from the feel of it. The switch is very positive and has a nice click detent, which is nice. If you look at the shield here that hides all the internal bits, it looks like it's just a sliding fit that fits on the spring. So I was wondering why it wasn't centered so much. I think that matters a lot less. This is set for gas, but this doesn't support gas, so that's not going to be a factor. So you just got to get the wire to thread through that center bit there. And it looks like the torch length on this, the cable length, is about 6 feet. And it's got a plastic sheath on it, so I would expect that even if it's high temperature plastic, you'll probably get some splatters that melt into it when you use it. Comes with a standard 110 plug, so it's 110, not 110 220, I don't think, although I haven't looked for a manual yet. Here's the flux cord wire it comes with, and it's nice because the wire was sealed in a Mylar bag to keep out humidity. And my understanding, like with stick welding especially, the flux that comes on the outside of the sticks, you have to keep that dry. So they have ovens to dry those before you use them. So the flux inside here is probably similar, I'm guessing. And so they sealed it in a vacuum package so that moisture couldn't get in. Other accessories that come with this guy are a TIG torch, and that's pretty bizarre, truly. So they've got the separate gas hose here for the TIG torch. And it looks like they've got some additional accessories for the MIG torch and the TIG. Oh, this is all TIG accessories. Okay, that's all TIG accessories in there, so we'll set that aside for now. It comes with a ground lead, and the ground lead here is exceptionally light. They're saying it's 25 square millimeters. Boy, super light. I'm really surprised at that. It's also fairly short, so I think this guy is going to be similar to the 6 foot of the length of the other thing. Yep, yeah, it's 6 feet. So it's got a 6 foot long cable and a small DINS connector on the end. They come with glasses to protect during MIG. I don't know. I've never seen passive glasses for MIG before. That's pretty bizarre. I think I'd still wear a full face shield. I think that'd be a lot safer. And comes with a stinger for stick welding. It's a pretty small one. Again, 6 foot cable. And a steel brush with a steel tip on the end, probably to break flux off. That's a very bizarre hammer that comes with, but they try to get you started right off the bat, and it comes with a user manual. And it does show you the higher current models here. So Vevor obviously carries more than just this model. This is their least expensive model. Looking at the spec page in the manual, they're saying the input current at 110 volts is up to 19 amps. So I guess you need to run this on a 20 amp breaker, although the AC cord for it is a standard 15 amp AC cord, as you can see right here. It doesn't have one of these terminals to the side, so it will work in a 15 amp outlet. You're not restricted, but if you run it full gas, you might trip a breaker. So looking down the list here, it's got a duty cycle 60%. I'm not quite sure 60% at what current. That'd be interesting to know what they mean. Power factor is 0.93, which is pretty good. That means that it's using 93% of the current it draws from the AC line gets used in the process, is what they're saying. Overall efficiency, 85%. Power factor has to do with drawing current out of phase. Efficiency can have to do with heat loss as well. So overall efficiency, 85%. So if you're drawing a kilowatt, 150 watts are going to be dissipated as heat inside the unit. So it does have a fan inside to keep it cool. In the manual here, they're saying this is suitable for material thickness between 0.8 and 2 millimeters. An eighth of an inch would be 4 millimeters, so they're saying this actually can't do an eighth of an inch. Again, I'm not experienced with MIG. That's the estimate I gave you was for TIG torch. The manual is actually written in pretty good English. That is a first. I am very impressed. It is very readable. So my first description of the front panel was wrong. Basically, you select between stick at 3.2 millimeter diameter stick welding. MIG, you either set it for 0.8 millimeter wire or 1 millimeter wire, and then lift TIG. And this no gas means it's never gas. It's not designed to work with gas, so that means it has no internal solenoid. Obviously, TIG requires gas, and you have to manually feed that down the line and start and stop the gas yourself. Every model above this one, pretty much, has a gas inlet. So if you look over here, the 130, the 200, the 250, and the 270 all have a gas inlet. They do make a 160 model without a gas inlet. So they got a 130, 160 without gas, then 160, 200, 250, 270 with gas. I've never loaded wire before in a MIG welder, so let's see if we can figure this out. I have watched Cutting Edge Engineering, so usually it's you loosen something like this and flip it out of the way and half of the assembly snaps up, and voila. So the top is a ball bearing and the bottom has two different diameter wire feed mechanisms. So I think you need to unscrew this and flip it around. Yes, there we go, 1 millimeter and 0.8 millimeter. You can see the groove thickness difference there. So you just flip that around and it's got a square drive dog, which is kind of neat. It's broached. It feels hardened, so that's kind of cool. And the locking mechanism is very simple. I actually didn't look to see what diameter wire it comes with. So T-nut, washer, spring, very lightweight, and a cover plate. So they thought about the design reasonably because there's enough thread sticking out that it's pretty easy to tighten this guy down without losing it. I don't know how tight that's supposed to be. We were set for the 1 millimeter, that's good. I do need to cut off a little bit of this. It's trying to unwind the whole spool, which is not good. So you definitely need to keep this under tension. Just give me a sec while I go get some pliers to cut off a bit of this. So I turned the power on so I could use the power feed to pull the wire in. So I've cut off some of the wire. Put the torch to 1 millimeter. Oh, I guess this thing's supposed to free float in here. I didn't know. So this is to set tension on it. That's interesting. Okay, that was pretty easy. I'll keep my torch hose as straight as possible. Let's see if it feeds wire all right. Well, that was really easy. Fed without any hiccups whatsoever. So I'm not sure how much you're supposed to leave sticking out. So I'll leave just a tiny bit. And I think we're good to go. That was really easy. So next we're ready to go. Just got to hook up the ground lead, which is really straightforward. There we go. Interesting, very flexible DINS connector there. A lot of rubber on the outside here. So we're good to go. So we should just set up something real quick and give it a test. All right, so we're going to try and weld something here. I've got my my TIG helmet here, or my arc welding helmet, some proper gloves. These are actually Harbor Freight gloves, surprisingly comfortable considering the price. I have no idea what I'm doing here, so I'm just going to try and get this to work. I know what it looks like to get a decent puddle on TIG, so I'm going to try and get a puddle on the MIG and then walk it. We'll see if that works. I don't know how much you're going to be able to see. Hopefully it will be something. This material's fairly thin. Well, it's like 100 thousandths, so I have no idea what I'm doing here. We'll just see if I can get it to work. Well, I blew a hole in it, but it actually wasn't so bad for start. I think the wire rate is too fast, which I think is controlled by the current setting. So I'm going to turn the current down, and we'll see if that slows the wire down. Doesn't spatter a ton. So using their supplied flux remover here, that's not terrible. I mean, other than blowing 2 holes through it, but we'll give it another shot, see if we can do it a little better. The voltage might be too high here. So the wire speed control is by current. So I know at the end there I had way too much wire stick out, but because there's no shielding gas, it doesn't seem to affect operation too much. And I'm sure someone more expensive MIG is just cringing at the poor technique there. So I was able to fill in my mess, and the spatter is not huge. You can see there that there is some spatter, but it's not a ton. I'm going to take this over and grind it down, see what it looks like inside the weld. So I just took the belt sander to the weld seam, and the weld is really good. I mean, it doesn't look great from the perspective of the welder itself, but you know, as far as beautiful looking, but it actually does a pretty decent job. The welder itself is quieter than the fan I've got here in the garage because it's 100 and something out here, so it's very hot. This does generate a little bit of smoke, but not a ton, nowhere near as much as I thought it was going to be. I thought this was going to be a much messier process. There is some spatter in and around here, but not huge, very clean upable, and it's not sticking. So I am really impressed with the quality of this. My skill set's a bit lacking, but we'll see what we can do. We'll try a couple more welds and see how it works out. So I didn't do any prep work, didn't clean anything, because flux, my understanding, doesn't require a lot of prep work, but that may be a total misnomer. So one observation I have is that I can't keep up with the wire feed. I turned the current all the way down to 37 amps. The wire comes out faster than I can deal with it, but that's probably a limitation I've got. This is also 100,000th material, so that weld's a joke. For my, my skill set apparently sucks in dealing with the MIG, but it seems like it's strong enough. It does seem like there's some penetration there. Here's the current all the way up. So I actually did better with the current all the way up and the wire coming out faster. It actually did a better weld bead. So it might be regulating the current with it simultaneously, which it says it is, but I had better luck there. So that's just my experience. I know that anyone who's done any MIG welding that knows what they're doing could probably give me a ton of pointers. I obviously have not, so this was the best I could do with it. Overall, the welder's really easy to use, and this is my first like 3 MIG welds ever, and strength-wise, I think these are passable. So that's pretty impressive. To test my weld strength, I put this in the hydraulic press and just proceed to crush it, and you can see that it bent the metal before it gave, but the weld did give before the rest of the metal did. Most of the force was right on this seam right here. The penetration is just so-so. If this was a TIG weld, that would not be a good penetrating weld, but it took a huge amount of force, and you can see that the metal buckled before it finally gave way here. So that's kind of impressive. Could have been better, probably just with more skill on my part. Doesn't seem like that's the welder's fault. Again, people with MIG experience probably could weigh in there and give me more information about that. All right, so this thing's held together with an impressive number of screws. 3 screws holding these plastic bits. 4 more underneath it, or 2 more on each side. Then the handle, 6 on this side. So this thing is a really stiff construction. And it's very expensive in manufacturing to have humans involved. So if you can minimize the number of fasteners, you save a lot of money, but you give up strength. This thing is a very rigidly constructed device. So here's the motor that feeds the roller in here. And here's the conductor that goes through, which they've got additional insulator on, and attaches to the roller down here, probably with a slip ring. The ground is carried through from the transformer. Here's the IGBT section under here. There's just a heat sink, so nothing exciting to see. They have a fan pushing air through it, and they enclose it just to keep this whole thing with a bunch of air pushing through the parts that get the hottest. Everything's conformally coated, which is good. The PC board is conformally coated, which means moisture won't affect and corrode the components, and the wires are all nice and neat. And then over in the high voltage section, you can see where they put gaps in the PC board to prevent arc over, to separate the incoming AC from the other circuitry, which is really nice. Not much to say about it. They've got protection MOVs in here and some capacitors. They look decent quality. They did carry the main current to the lug here that is for the TIG, and the stick also goes through here with that wire to the roller on the other side for the MIG. And this is aluminum, so they've got dissimilar metals. Not always a great idea, but definitely save the money. If this was copper, that would have been very expensive. This also is aluminum for the ground lug down here. Or actually, that's the positive. This is the ground. Nothing negative to say. The construction is very good, and the number of screws they use definitely is an expensive choice on their part. So it looks like they didn't skimp. Let's see, can I tell about the caps? The caps are 105C, so they opted for more expensive caps that run at higher temperature. So they're bigger and more expensive, but they did anyways because this is a high temperature environment. So you get some longevity out of that, and then you get some big caps here for the switching supply. These are only 85Cs. They would have been even bigger if they're 105Cs, and wouldn't have fit in the case as easily, so that's probably why they chose this. That's not ideal, but you know, this is an introductory level machine. Probably not one you're going to use every day for, you know, decade on end, because that's not the kind of machine it is. It's kind of a hobbyist use once in a while. Probably last forever. So pretty nice. Have nothing negative to say about the construction. Separate front panel PC board, interfaces with the ribbon cable, and they use some adhesive here to make sure the ribbon cable connector doesn't loosen itself. They also use some sticky stuff to keep all the other connectors in. Not too much so that you couldn't get it undone, but enough that it won't vibrate loose. There as well. Not bad. They didn't glue the big caps down, which is common if you're going to worry about something surviving a vibration environment. So they didn't do that. They didn't, typically with caps in general, because they're a big, heavy, bulky item, especially the larger ones, you would glue them down, but they didn't do that here. Like I said, the caps are 105C except for these big guys here. Probably because if they went 105C instead of 85C, these guys wouldn't have fit because they're right at the edge of the package. Overall, the build quality of this Vevor 130 amp Mig Welder is excellent. Remember, it also does TIG and stick. The controls are very straightforward. The manual's in legible English, which is really impressive. The general quality is decent. It's not something that you'd use for a business, but for a home gamer, especially a beginning home gamer, it's pretty good. If I were looking for one, I'd probably spend a little more money and get the one with the gas bottle. That way you could do TIG with a, you know, gas control valve built into it if you wanted. It would also let you do double shield MIG, which would be nice. But really don't have any complaints. Long term, it'll be interesting to see how well the plastic wire feeder stands up, but there's metal in all the right spots here. The inlet is a spring, and the two pieces that keep the wire, there's a very common ball bearing here that presses the wire up against the feed roller. The feed roller has two different drives in it. I don't know what the slip ring assembly is like. Didn't really want to take that apart. Overall, I think it's pretty decent. Nothing high end, but the price is not high end either. It was only $129, so I think it's an excellent excellent value for the money. They put a little bit of extra effort where it counts, and so I don't know. Time will tell, obviously, but I give it a thumbs up.